Hello, today I'll be demonstrating Coltraco Ultrasonics Portapipe liquid level indicator designed for finding the liquid level in horizontal or vertical pipes or small cylinders or other containers. I'm going to be demonstrating today how to find the liquid level both on horizontal and on vertical containers, and I'll be using this glass container first so that we can see quite clearly what's happening with the liquid level here, and then I'll also demonstrate on this steel pipe that we have over here as well. So to start with, I'll talk you through some of the settings on the device that might be relevant to your testing. So I'll turn it on, and I'll go down to System, and you see we have a few settings here: probe, fluid type and fluid speed of sound. They won't be relevant right at this stage because we'll be asked to provide those as we start our measurement, so ignore those. Vessel diameter as well we will be asked for as we set up for a measurement. However, vessel material, vessel speed of sound and vessel wall thickness are important if you want to get the most accurate possible results out of your Portapipe, and you'll have to go into the settings to change those manually. So I have this all set up already for glass, which is not in our material database. So what I've done is I've gone onto vessel material and selected other, and then I've gone to vessel speed of sound, and this by default will go to 5,920. However, for glass, the speed of sound is 4,540, and I just found that by having a quick look online. So if you have a material that's not in our database, you can always select other and then just add the speed of sound manually, as I've just done. And for the vessel wall thickness, I measured this before I started this video with the Porta Gauge 5 Coltraco Ultrasonics thickness gauge, and that was 4.3 millimeters. So I'll leave that as it is. We then got gain auto, and I've got this set to no, which means that the gain will not automatically adjust, and that's just because I'd like a bit more control so that I can demonstrate what happens as we change the gain. However, gain auto you may find a little easier for general use. And then we've got measurement units where we can switch between metric and imperial. I'll leave everything in metric for now. Load defaults, which just resets all the settings to their default values. Test, information, LCD backlight and audio are all just about various other parameters on the device. They're not to do with the actual level measurement process. And then we have at the bottom here, we have level threshold, which simply sets the amplitude of signal that this device needs to detect in order to identify that as a potential reflection. We have this set for now to -10, and if we need to adjust that later we will do, and we'll talk about why you might need to do that. And then we have probe blanking, which is a period at the start of the measurement where the device does not listen. This is to avoid interference with your measurements from things like the walls of the container ringing, which they can do, particularly with metal and metal containers, and we don't want that to interfere with our measurement and give us false levels. So I have this set to 25 microseconds, which is a pretty good baseline, and again you may need to adjust that, and we can talk about that more if we have to do that later. And then finally just probe power, which I have set to low. You could change that to high if you had a large container or a particularly attenuative fluid. Some oils can be quite attenuative to ultrasound, so you may want to use the high power setting for that. But that's everything for us for now, so I can press 1 to go back to the main menu, and I will now press Quick Start. So it's going to ask us what probe we're using first of all, and today I'll be demonstrating using a 2.5 megahertz 14 millimeter diameter probe. So I can select on the screen here the 2.5 megahertz probe, DE 2.5, and you can see that's recommended for 100 to 330 millimeter diameter containers. And then I will select our fluid, which is just room temperature water in this case, so water at 20 degrees. And then the pipe diameter I input earlier, I've measured this with the tape measure, and that is 130 millimeters. So press enter. And now we're ready to start measuring. So the first screen is our A scan, and this is where we see the full waveform of our received response. So I'll connect my sensor, and I'll place this at the base of the container. So for horizontal pipe measurements, we do need access to the bottom of that container because the Portapipe is going to transmit an ultrasonic signal through the walls of the container, through the liquid, and that will reflect off either the opposite wall of the container or off the surface of the liquid itself. and we can use that to determine how much liquid is in the container. So I've got this raised up on a couple of bits of wood here, but if you had a pipe, you just need access to the bottom of that. I've already applied some ultrasonic gel to the bottom of this, and that's just so that we can couple the sensor to the wall of the container nicely. So with that all being done, we're now ready to place our sensor on the underside of this container, and then we can observe the A-scan to see if we can identify a reflection. And as you can see, we have an initial period of some ringing there on the far left-hand side of the waveform, and then just a little bit further on, maybe 20% of the way along, we do see a little bump in the readings, or a little bump in the graph. It's not very clear, but it's more than clear enough for the device to detect. But if you want to see that a little bit more clearly, you can increase the gain by pressing 2, and this will increase our gain by just 1 step, and I'll increase it a couple of times so we can see really clearly that we have this very nice reflection that we're detecting. And actually, if we compare this to, I'll take it off for a moment, we have these couple of bars below our graph, which if you can see this, the top one has got 2 lines here, and the bottom one has got 1 line in it, or well, 1 line that moves around and 1 line that is fixed. The fixed line in our bottom bar indicates the exact position of the theoretical liquid level response time, and the top bar indicates a range of acceptable values based on minor errors that there may be in the time of flight measurements. And then the moving bar that you can see is the bar that's going to lock onto whatever peak this detects and whatever reflection this detects that it thinks is the liquid level. So you may be able to see this container. Yes, you can see. This container is not full of water, so we would not expect to find our reflection in this expected window. We'd only expect to see that there if the pipe was full. And because we can see this isn't full, we are expecting to see this somewhere in the window beforehand. So if I place this back on and let that update, you can see, as expected, we do have a reflection there, and it is in between the start of the transmitted signal and the expected arrival time for a full pipe. However, to make this a little bit clearer, if I press enter, I can take us to, first of all, we have a screen here which has a bunch of values which are primarily going to be useful for diagnostics. So it gives you arrival time, it gives you your signal strength, your noise level, signal to noise ratio, and your current gain. However, if I press enter one more time, it takes us to a screen here where we can see a percentage fill value. And as you can see, we're measuring this at 46.5% full, so just a little under half full. So what I will do now is I'll take the camera and I'll bring you down to the level of this container so you can see that we are indeed just a little under half full. So there we go. That's how you would use the Portapipe to find the liquid level in a horizontal container such as this. Now for a vertical container, the principle is going to be very similar. However, the way we actually do this is slightly different. We can still use the same values that we did before, or we can just use the A-scan, but the way we interpret these values will be slightly different. So all I've done now is I've turned this up onto its end, so we now have a section of essentially a completely full pipe until about halfway up, and then a completely empty pipe for the rest of that. So I've applied a good amount of gel here, making sure to cover the liquid level. So I've got a good amount of gel below and a good amount of gel above. And first things first, what you can see when I have this sensor just in air is that the values on our screen are just changing around randomly, and that's because if we go back to our A-scan, the device is trying to find a peak to lock onto, but of course we have no received signal, so it's just choosing the largest value that it can find at any moment, so that's going to vary a lot. And that's going to be quite important because that's, broadly speaking, how we're going to identify the level when the pipe is vertical, or the cylinder is vertical. So all I would do for this is I would place my sensor below the liquid level. Oops. And here you can see when I do that, we do indeed get a reflection. I can't apply much pressure without pushing this, so here we go. There we go. So we can see a reflection, and this time, if you can make that out, that reflection is indeed arriving in our expected window. So I could use this A-scan and see that I have my reflection here within the window, and then if I place the sensor above the liquid level, you'll see that I get no reflection. I get a little more ringing at the start because there's nothing to dampen those vibrations, but I get no reflection. So I could use this as my metric and then move my sensor down until this reflection appears. If I go until I'm just below the liquid level. And there we go, the sensor's now just below the liquid level, and there you can see that reflection just starts to appear exactly as we enter the liquid level. However, to make things slightly easier, you could also go back to our percentage fill screen. However, this time we're not looking for a specific number. What we're looking for is just 100% when we're below, and then when we're above the liquid level, you see that value will just bounce around quite randomly and won't fix onto anything. So now as I move down, there'll be a point where, there we go, that the device just locks onto 100%, and as you can see, that's the moment that the sensor has just about entered the liquid. So that's the basic operating principle for vertical and horizontal liquid level measurements using the Portapipe. Now I'm going to move over to the steel container so that you can see a bit more of a real world example. Okay, so I have filled this pipe up now to just about halfway full again. Now, of course, this time we aren't going to be able to see what's going on inside the container, but you've seen that the liquid level is just around halfway up the cylinder. So we'll see what we can do. So again, I'm going to apply a nice strip of gel, making sure that I'm definitely well above and well below the liquid level so that I can't possibly miss it. And we are going to have to change a few settings this time. So I'm going to go back into my system settings. Now none of these will have changed. However, our vessel material is now carbon steel, and I can just select that. Now I don't need to mess with the vessel speed of sound for this one because that is in our database, so that's automatically set. However, the vessel wall thickness will have changed slightly. Now I know these pipes have got a 3mm wall thickness, so I'll change that to 3mm. I will leave gain auto off, and our level threshold, probe blanking and probe power will leave the same for now, and if we need to change those we will do so in just a little while. So I can go back to the quick start menu and I'll start again. So still using the 2.5 MHz sensor, no change there, still testing with room temperature water. However, the pipe diameter now has changed, so I'll quickly measure that. That has now changed, and it is 126mm. So it hasn't changed by much, but it has changed a little, so 126mm. And I'm going to demonstrate vertically this time first, and then we'll move on to the horizontal. So we are on the percentage fill screen, and just as before, I'm going to place this on the container, and we should see 100% when we're below the level, and when we're above the level, that value will just bounce around. And then if I move the sensor down, we're looking for the point, there we go, where that switches from random values to a solid 100%, and that's going to be our liquid level. So with my sensor placed on here, if I just take the camera, you may be able to see, there's our liquid level, there's my sensor. I'm not sure how clear that is, but it's just, as before, the sensor has just dipped below the liquid level, and our readings change from random to full. And I'll just again show you the A scan on that so you can be completely clear. Here you see we have a reflection there within our expected window, and above we have no such reflection. You may notice, I'm not sure how clear it is, you may notice there is a little more ringing on this pipe, and that's because the walls are made out of metal rather than glass. Metal will ring more and reverberate for longer, so you may need to be a little careful with your probe blanking, especially if you have thick-walled, large diameter pipes. It may be that you need to increase your probe blanking time in order to cut out that ringing. And the way you would do this simply is, or the way you would know if you need to do this first of all, is If you're placed well below the level, and you can see that you have a reflection in your A scan, as we'd expect, but the device doesn't seem to be picking up on that, that would be an indication that your probe blanking is a little too low and it's picking out something in the ring down of the container. And to change that, you would just press 1 to go back to the main menu, go into System, and then you could go down or up to probe blanking, and you would just increase this value. Now for us, it wasn't a problem, so I'll leave it as it is. I'm now going to seal up this container to the best of my ability and try and perform a horizontal liquid level test on this steel pipe. Okay, so I've now sealed up the pipe. Nothing seems to be leaking, which is good. And I've placed it horizontally here on these 2 blocks of wood again, so that I can get access to the bottom. And I've got us here on our measurement screen again. Nothing has changed in our readings. I've not emptied any water out of the container when I've sealed it up, so we're still expecting this to be something around half full. I haven't changed the speed of sound of anything, I haven't changed the fluid, the material of the walls of the container, so I've just gone straight back into a measurement, and here we are on our A scan. And I'm going to place the sensor just at the base of this cylinder. And just one thing to note, if the readings on here seem to be a little inconsistent, that's just because this wants to move a little as it's not really fixed in place, and I'm trying to focus on holding this up to the camera so you guys can see clearly whilst I'm getting this sensor placed nicely at the bottom, so I may be moving around accidentally, but if you're able to just sort of focus and place this on the bottom nicely, you should see very nice consistent results. So I'll go and I'll place this on the bottom, and we'll see if we get a reflection. And so you can see that we do indeed have a reflection. In fact, we have a couple. I might need to increase the gain slightly here, but it may be that we're fine. So you can see that we do indeed have a reflection there, about halfway between the expected arrival window and the start of the signal. And our device has locked onto that. If you see the mobile bar on the very bottom, that has locked on. So if I press Enter and go back to our percentage fill screen, we can see that we are indeed at about 51%. As I say, these readings are varying slightly. That's just because I'm moving things around slightly by accident as I'm placing this on there. But if we get that fixed into a nice place, we should be so 51 or 51% is looking about right. So as expected, we filled this about halfway, and the Portapipe is telling us we've got something like 51 or 52% filled. And that's how you would find the liquid level on a horizontal or vertical pipe using Coltraco Ultrasonics Portapipe Ultrasonic liquid level indicator.